It's really great to see all of you. I hope you are having the wonderful day at the conference. So my name is Paulina Sadowska, and I'm an engineering manager at Allegro. I also have worked as an Android developer for about 7 years. About 2 years ago, the product my team is building encountered a significant challenge. And during this presentation, I want to share with you how Kotlin Multiplatform helped us find a solution to our problem and helped us overcome that challenge. And since about 2 years have passed since we launched this project, this part of the project, I will also share with you what went well inside this project and also what were the a little bit more challenging parts and what we learned along the way. So, as I mentioned, I work in Allegro, and Allegro is the leading e-commerce platform in Poland. In our company, there are about 100 mobile developers who are creating the Allegro app, which is built natively for Android and iOS. And all of those people, all of those about 100 mobile developers are working really hard to support the needs of millions of users we have in Poland and also other countries in Central Europe. My team is part of the technical platform, which means that we are not building the features directly, but rather we are creating the tools that will speed up the work of other developers. So our goal is to speed up their work, but not sacrifice the quality of our app and the developer experience. Our team in Allegro is building the server-driven UI platform called MBox. And this platform powers about 50 screens inside our app. MBox allows developers to create the definition of the screen completely on the backend. And this definition can be rendered on both Android and iOS, and our mobile engines, our MBox mobile engines will render such screens using native Android and iOS views. So for example, let's say some developer wants to display an offer, and such offer should contain an image, some badge, label, some price, etc. All of those UI elements can be arranged as the developer pleases using different containers and also different layout parameters. And as you can see, this is like regular Typescript code, but with some custom components that we've implemented that are really similar to React components. But under the hood, such code is not sent to the apps directly. It's serialized into JSON format. And this JSON can be understood by our mobile engines, which will render such screens using native Android and iOS views. So as you can see, this offer is looking very similar. It has consistent look and feel, but it also is not the same because we respect the differences between Android and iOS platform, and also we respect differences there are across in our design system, in Android and iOS. And such screen, such offer can be embedded anywhere inside our app. So we allow the combining native development with MBox development. When we've designed MBox, our main goal was to allow creating with it so-called content screens. So we wanted to wanted to speed up the development of screens that have frequently changed content, but not so many interactions with the users. So screens such as the main page, when you have a lot of offers, the layout changes constantly. There are new promotions, new campaigns every week and every day even. But interactions are limited just to opening new screen, sending some track event, or showing some simple message. We never intended it to be used on the whole app because our reasoning was that for screens that contain a lot of complicated business client-side logic and screens that contain highly interactive content, Such screens are better off when they are implemented natively, because native platforms give developers all of the power that there is inside the Android and iOS platform, and we don't want to overcrowd our platform with features that will be used only on one specific screen. So that's why our platform, from the very beginning, had a very well-designed set of reusable view elements that allowed to create even very complex screens, but interactions were pretty limited. And at the beginning, it looked like a pretty good strategy. We've released MBox to production in 2019, and at first, it was used to render the main page of the app, and after that, it started to gradually get traction and be used on more and more screens. And now it powers about 50 screens, I think, inside our app. So everything went well for a while, and but after some time, developers started to worry and started to question whether it is safe for them to use MBox. And why were they worried? Well, you see, even simple so-called content screens from time to time need to introduce some simple client-side logic. They need to, from time to time, add some interactive element, for example, add some simple form on the screen. And developers were worried that if they use MBox and the business will give them a requirement to do something that will require client-side logic, they will be blocked. They will not be able to fulfill the needs of the users. So that's why we needed to do something to address those issues, and we needed to do this pretty fast. And to solve our problem, when we analyzed all of the needs of our developers, we realized that we need to add 2 new mechanisms to our platform. We need to add a support of view binding mechanism, and also we need to add a support for the client-side logic. And let's start from the first one. View binding is a mechanism that allows to read the state and update the view based on the values that are saved in the state. So, and this is a pattern that is really familiar for example, front-end developers who use React. They have a state, they bind some values from the state to some parameter inside the view, and if the state changes, they do not update this view manually, but just this view will render automatically using the new value in state. And this is like the very simple use case. When I have like value in state, I want to display it directly inside the text view, but more often developers need to do something with that data before it is displayed. So for example, they have to process some data that user inputs and display some validation message based on the fact if the data is correct or not. So that's why, complementary to the view binding mechanism, we also needed client-side logic that will allow process this data client-side. And this is the part, the client-side logic part is something I want to focus on during this presentation, because this is the part that where we have used Kotlin Multiplatform. So what do we need to implement client-side logic within our project? To support client-side logic, we need to allow developers to define arbitrary set of instructions. So basically, we need to allow them to write some code on the backend and send this code to our clients, to the app, where our mobile rendering engine will be able to understand these instructions, understand this code, and process it using values in state as parameters, as an input. And having this set of instructions, having the inputs from the state, this engine needs to provide the result that will be, for example, displayed on the screen. And as I mentioned, MBox mobile engines are implemented natively. We implemented it on Android using Kotlin, of course, and on iOS using Swift. And both those languages are compiled languages, so it is not possible to get some arbitrary Kotlin code, write it on a backend, and send it to the app and execute it on the fly. It does not work that way. So we needed some different approach to allow that. And the first solution that may come to mind is using then some maybe interpreted language, right? We have like JavaScript that can be theoretically used inside our project. And it seems like the fastest way to tackle that problem, because that's the engine that is already there, right? And it seems like a faster solution, but it also comes with some drawbacks that caused us not to use that after we analyzed that. So it was critical for us that when we implement the client-side logic engine, we can ensure our developers that it works consistently across platforms. So we can assure them that both platforms, both Android and iOS, support the same set of operations. And also, if they have some operation and some input, this operation with given input will produce the same results on Android and on iOS. And as we've analyzed different JavaScript engines, we realized that each of them had slightly different capabilities. Also, some of them were not actively maintained. And as we analyzed that problem, we realized that the only valuable option for us might be to use the engine called the JavaScript core. And on iOS, it looked pretty great because JavaScript core is natively supported on iOS, so we saw no significant risks there. But on Android, it's not that simple. Why? Because JavaScript core is not natively supported on Android. It needed to be added as a separate dependency. And it turns out that this dependency is pretty huge. It had significant impact on our app size. It was about 30 or 40 megabytes. And this is something that could impact our users and can it can prevent some users from downloading our app. So it was pretty serious drawbacks that basically meant a red light for using JavaScript core in our project. Another things that made us hesitant to use JavaScript engine in our project was that, from our perspective, JavaScript core engine is a black box. We cannot ensure ensure what operations are supported and how they work for different inputs. And it's also hard to make sure that each of this engine will work consistently everywhere. So given all of that drawbacks, we decided that JavaScript is not a way for us because it comes with too many risks. And instead, we will create something custom. We will create custom client-side logic engine. So what do we need to create custom client-side logic engine? To create it, we need three elements. We need three layers, basically. We need, of course, the engine, which is a core of this whole project. But we also need a contract, a layer that will both backend and our engines will understand. And last but not least, thing that is really important, the developer-friendly language, because we don't want our developers to directly interact with the contract, which may be too complicated and not easy to use. But we want to provide them with tools that will make writing this logic as seamless and as easy as it's possible, as is physically possible. So let's start with the middle. So let's start with the contract. As a contract, we've decided to use something that is already there, but it's I don't think it's like really popular. we've decided to use a format called JSON logic. And JSON logic is not by no means a full-blown programming language, but it's rather a format that defines how to define some operations in JSON format, and also how to combine operations together to define more complex business logic. So, for example, here you can see some use case, some example code written in JSON logic. And as you can see, we have a couple of operations here that are combined together. Here we can take value from our state, read value from my state that is saved under the key password. Then we will take this value and check what is the length of the password. Then we will check if this length is smaller than 8 in this case. And based on the results, we will either return some validation message, and we can display this value to the user, or we can return nothing, and then no validation message will be displayed. And JSON logic, by design, supports about 30 different operators that are, as you can see, as you saw in the previous example, pretty atomic. And those operations together can be used to define much more complex logic. And this format is also extendable by design. So right from the start, we also knew that 30 operations, it's a little bit too little for our needs. And we knew that we will also need to add some additional ones to be able to make sure that, that this tool is powerful enough for our developers. But there were not that many operations that we needed to implement. I think we ended with about 60-something operations that were either defined in a JSON logic format or were like picked by us. Basically, we just like checked the standard Kotlin standard library and saw what of the operations can be useful for our developers. Okay, so that's the contract. That's the layer that backend and engine will understand. But of course, our developers would not like to code like this. It will be pretty inconvenient to write JSON to write code, right? And that's why we also added the abstraction layer that allows creating such expressions in TypeScript. So as you can see, here is the same operation written in TypeScript. It looks like regular TypeScript, right? But it's not. There's not like regular TypeScript code, because this code will be converted to JSON and sent to our clients in the JSON logic format. But our goal was to make this abstraction layer as similar to the TypeScript code as possible. So our developers who use Ambox, who are mainly front-end developers, are using it with ease. Okay, so I've talked about the contract. I also talked about the abstraction layer that we've built for our developers. But what about the core of this project? What about the engine? So we've decided to build the client-side logic engine using Kotlin Multiplatform. And why Kotlin Multiplatform? Well, there are a couple of reasons. And the most obvious one is that using Kotlin Multiplatform allows us to target both Android and iOS projects. So we can write code once and use it on Android and iOS. And it's great in terms of the speed of development, of course, but it's also great when it comes. It was also great because of other reasons. That was even more important to us. Having the shared code base for Android and iOS made our product consistent by design. So we could ensure that by design, all of the operation will work the same on both platforms, which was pretty huge for us because inconsistencies across platforms are main source of bugs when we create separate projects. And of course, we want to consistent look and feel for both of them. Okay, and how does this project works under the hood? So for each operation, we've created separate objects, separate class that will be like pretty similar. So we will always take the parameters, we will unwrap them because JSON logic format can provide us with arguments of any type, and Kotlin is safely typed, as you know. And having this expression, having these parameters, we usually just call standard Kotlin function. So it looks like that. For very rare cases, when we needed to provide separate implementations for Kotlin and for Android and iOS, it was also very simple to support that because thanks to the actual and expected feature. So here you can see one of the example of one of the operations that required different implementation on both platforms because they were not supported in the multi-platform code. Because we have used Kotlin Multiplatform, the integration on Android was trivial, and integration with iOS code was also mostly easy. I say mostly because it came with a bit more challenges. And what were those challenges? When I asked our iOS developers, they pinpointed that it took them, the workflow for building Insta framework was somehow complex to build. So it was something that took them a little bit more time. Also, at the time when we created it, it was also no possibility to debug this code from the iOS project. So it's nice that it's changing now, as we all saw during the keynote, because it was really hard for them to just be forced to rebuild this project over and over again to test their changes. And also, our iOS developers mentioned that the code that is generated from Kotlin Multiplatform, the Swift interfaces that are generated, were not always that great from the beginning. They needed to tweak this code a little bit to make them as good as they needed to be included in our project, basically. But all in all, the integration on all platforms was a success and was like mostly easy. And because we've built this project in Kotlin Multiplatform and because we've created it from scratch, it was also really small. It has almost no impact on the size of the app. Well, definitely not the impact, as big impact as the JavaScript core would have. And because we have implemented it from scratch, of course, we had a lot more work, but we also have a lot more control over it. So we can ensure the quality of the engine, and we can ensure what is supported in it and what's not. And since about 2 years have passed since we released that, it worked pretty stable and generated very little maintenance work to us. And this project is part of the Ambox that is open source. So if you want to take a look, you can open this link and see this project. I know this is like pretty specific use case that not everyone needs, but I think it's really it might be really interesting project. Okay, so what were also some of the challenges that we encountered? Well, it was not related to Kotlin Multiplatform directly, but also the architecture of this project was a little bit challenging because we wanted to make sure that developers can easily plug in new operations to the project, so it's not getting overly complicated when we add too many operations to it. And also something that was a little bit frustrating for us who were used to the simplicity of Kotlin type safety. Well, JSON logic based on JavaScript, and we also needed to handle some of the very strange use cases inside our engine because like it's obvious for JavaScript developers somehow that string1 is equal to one, but string true is by no means equal to Boolean true, right? But all in all, the whole project was successful and we managed to implement it on time. And it helped us to ensure developers that can use this platform safely, even if they will be needing to add some client-side logic or something a bit more complicated to their screen. And of course, we still do not want to overuse Ambox. We still don't want it to be used on screens that contain a lot of complicated business logic, a lot of interactive content. We still think it's better to write them natively. But for cases where it's required for the screens, developers will not get blocked, basically. And this project is just one of the many use cases of usages of Kotlin Multiplatform inside our company. Other mobile teams used also Kotlin Multiplatform with success in other projects. For example, one of the mobile teams created the library for deep link navigations for our app, so we can share deep links across Android and iOS. Also, another team created multi-platform business tracker that allows sharing the definition of the events. Our team that works on the design system also uses Kotlin Multiplatform to share price and date formatters. And also I saw some example where the team uses Kotlin Multiplatform to share the contract of some complicated API. So I think our use case shows that, well, Kotlin is definitely not a tool for every task, but I think our use case shows that it's good to have it in mind when creating some even really complex projects because it can really simplify your work and it can really get it handy. So that's all from me. If you have any questions, just feel free to ask them, and thank you.